Okay, I'm going to talk about some things that are interesting me sort of in my regular day-to-day life, things I think about. I sort of the things that I'm thinking about intellectually at a particular moment, I don't make videos about them. I make spin-offs, like the principles that they make me think about. I make videos about that. And I'm kind of putting my foundation out there. And so I just mentioned a video I made to Donna Kate, I do this a lot, and in a way, it's almost like I feel like I'm trying to make you as bored, uh, not bored during the process, but by the end, you're like, okay, I've heard enough about the epistemology. I get it. I disagree with this part. That makes sense. I'm thinking about that. Whatever you think, but you got it. So, yeah, I'd like to talk about the questions that I have. These answers are, I'm a skeptic. I prefer questions to answers. I'd rather share my questions and run into people that could go, hey, I got some answers on that. Okay, not that I don't do that, but still, you'll see what I mean, because even when I get to these higher complex levels and start to ask more questions, it doesn't really relate to the high level stuff. And this is, for example, part of what I'm doing here in terms of, I've not been talking about politics. I think about this kind of real world stuff quite a bit. It just hasn't been the purpose of this YouTube channel. Okay. So things I've been thinking about lately, or in general for a long time, keep me occupied. Okay, one is this Kepler mission. Okay, I should have prepared this because I'll get the numbers wrong and stuff, but um, there is a spacecraft telescope that has gone up. What it does is it's looking at a particular part of the sky, and I think there's 40 million stars in there. It is able to look every half an hour, take a picture of over 100,000 of those, and every minute it takes a picture of about 500, 512, something like that. Now, an interesting thing here is all the data we're losing, because this thing actually, I think pretty much, it takes a picture of these 40 million stars um, once a minute. But it can't get all that data down, so it has to do data processing, and it only has so much time, CPU time on its computer to do data processing, and that's why it only gets to do 100,000 stars. Now, the resolution isn't great, but it's very, very sensitive to how much light is coming there. Excuse me. And it's going to look for Earth-sized planets at an Earth-sized, in the what is it, the habitable zone. That's it, the habitable zone around sun-like stars. Okay, and this is sort of, obviously it's subtly, um, not so subtly, to look for life, but it's not to look for life. It's a solar system formation question. We can see that there are, for a while we weren't sure if there were planets. Seemed like there should be. We've seen gas giants; those make a lot of sense. Do the little hard rocky terrestrial planets make sense? Or is that something special? I think probably they're common. Now, out of 100,000 stars, because uh, you need the plane, the plane of the solar system matters. We have to be in the plane of the solar system for this thing to detect these planets. I'll tell you how in a second. I probably should have said that ahead of time. Um, you'd only see out of 100,000, 100 or 200. And they'll watch for a couple of years. It's been up here now, 4 years or so. And because they're Earth-like, they take about a year to go around, and so we can watch them go around, 4 times. Because what has to happen is the planet has to come in front of the sun. Now, the planet the size of Earth is tiny compared to the sun, but it does dim the sun. It casts a shadow and dims the sun just a little bit, but it's very, very sensitive. Well, what they do is they watch the light from the star, and if it dips down for a while, the way it dips, you can see that it's a planet traveling in front. You also pick up solar flares and all kinds of other things, but they have kind of a different curve. A round body coming in front of a round disk that has kind of a curve that you can figure out how big the thing is. And if you watch several years, you can see how long it takes to go around. And you can figure out how far away it is all through this, all without actually taking a picture directly of the planet. This is amazing, because now I think my prediction is that Earth-like planets will be common. So we'll find a couple hundred of these things. Okay. Then we know where to look. The next thing in store is to have a space telescope that can actually take pictures of an Earth-like planet at an Earth-like distance around a sun-like star. A sun-like star. And the way you do that's funny because like the contrast is like 1,000,000 to 1. The planet's in there, but it's in that glare of the star where the contrast to see that is about 1,000,000 to 1. With the solution to that seems pretty surefire. What they've got is a different kind of lens. Instead of a regular lens, you have a warped lens. If you have ripples in your lens and you shine light through it, you can see these weird ripples um, as a result. Well, if you do this particular shape, what you do is you take that glare of the star and you get these bright bands, okay, like points coming out, kind of like an artist's rendition of a star rather than a real star. And what it is it's all that light folded into the parts where there were ripples in the lens, basically, right? Focused by that. And then you have dark patches in between. That's also made up of real light. And what is the dark patch? Well, that's 1,000,000 to 1 contrast. And so the thing is, you have an image where there's these wedges where you're getting 1,000,000 to 1 contrast, and then these bright saturated parts that are not useful. So what do you do to get a good picture? Well, if you want, you just take 2 pictures. Take it this way, rotate it, take it that way. Do that a couple times. You'll get rid of the bright parts. You'll be able to subtract out the saturated parts, ignore them really, and have an image that's 1,000,000 to 1 contrast. That's pretty good. So we'll actually see the Earth-like planets. Well, when we do that, we'll take spectra of them. We'll split their light into spectra. That allows us to see what chemicals are on that planet. And if there's oxygen, then there's life. As far as we know, there's no other way to have a lot of oxygen. The reason is there's other ways to produce oxygen, but oxygen in a matter of very short geological time is absorbed, turns into rust, and oxidizes things. So, so if you see an oxygen atmosphere, would be a pretty good sign. And this is all going to unfold in the next half century. So many of us are going to be here to watch this. It's a momentous time. And it's really, we're going to have these planets found in the next 4 years or so. It's going to find them. And if it doesn't find them, it means that it's rare. And we can confirm that. I'd rather see other planets and find life. But if we confirm that it's super rare, that's interesting as well. Scientifically, that's just as exciting, but as sort of an anticlimax, right? Because then it's like, we are alone, or we may be alone, or maybe we're not alone, but we're so alone we'll never find the other people we're not alone with, or whatever. Okay. Seems like I had 3 things, but now I've forgotten the third one. The other one I was thinking about, I just always do, is I love to picture my place in the universe. Where I am. Like when I was a kid, somebody had said, well, there's only going to be time for 2 anyway. But when I was a kid, I remember hearing, oh, you move in 8 directions at once, because, and the idea there, I said, how could you do that? Because you can only really move in one direction. But then the idea there is, of course, you move relative to the Earth, you move relative to the pole of the Earth, relative to the sun, relative to the galaxy, relative to other galaxies, something like that. I don't know how they got 8 or if it was even 8. But you have all these relative motions, and I love to picture that. There's a couple good programs, Celestia being a main one. But it came up with this Leonid meteor shower, which the weather wasn't good. I didn't end up going to see. But meteor showers are usually good to see after midnight. And the reason is that before midnight, you're on the back side of the Earth. Right? The Earth is spinning. And before midnight, when you're looking off in space, you're going away from that. Your orbit, you're sweeping around the sun. You're shooting at a high speed away from what you're looking at. But come midnight, you swing around onto the forward-facing side. That's why it's a good time to see the meteor showers, because the meteor shower is caused by the Earth sweeping through a previous trail of a comet or some cloud of dust. But I think they're pretty much all trails of comets. So the scheduled ones, and you're sweeping through it, and so you got to be on the forward-facing side. And I love that kind of thing. It's also when I call people around in Hawaii, so I call people, a lot of them are 6-hour difference, even friends in Europe, 12-hour difference. They're on the other side of the Earth. They're upside down. I'm talking to them on Skype. They look right side up, but it's because their camera's upside down too. They're on the bottom of the Earth. Love to picture that. I think this is a healthy thing for me to always try to picture my geometric orientation with all these different bodies. Because obviously we're evolved to just think, oh, the Earth is there, and even though we know it moves and everything, we pretty much keep the old ancient view, that because it's way good enough as an approximation, and it's actually kind of a danger to think about too much other stuff. I'm running out of time. But in reality, we can update our view and actually realize that we're moving, we're spinning around we're on like one of those treadmill type things. It's the whole planet Earth.